Okay, we're going to go through example number 3 here, which is on using the Pythagorean theorem. It's basically the same as we've already seen, just with slightly larger numbers. Um, so the scenario here is that a summer camp is building a new zip lining course. The designer of the course wants the last zip line to start at a platform 450 meters above the ground and end 775 meters away from the base of the platform. How long must the zip line be to meet the designer's specifications? So visualizing and describing it, we're saying that this is kind of the triangle we'd be building. Okay, the base of the platform and the ground should be approximately perpendicular. We don't want the platform to be at some weird angle. We need to find the length of the zip line, which is the hypotenuse of this right triangle. Okay, so we should be able to go through and say that a squared plus b squared equals c squared. So 450 squared plus 775 squared equals c squared. Okay, where c is this black length right here. Okay, so now we can go through and we can start finding values for that. So let's say 450 times 450. That is going to give us 202,500. 775 squared is going to be 600,625. Therefore, together, if I add them up, I'm just going to do this by looking at the place values. So 5 and 0 make a 5, 2 and 0 make a 2, 6 and 5 make 11. So we have to carry the 1 into that position. And 2 zeros make a 0. So 803, 125. Let me see if I got that right. 803, 125. Okay, so that is my c squared. Our last step is to take the square roots of both sides. So we get 803,125 equals c squared. Okay. Now, this simplifying step that they show where they say it's going to break down to 25 square roots of 1285, that is because they have figured out that there are perfect squares in there. Now, this is a really large number. So to do this step would be kind of difficult. Basically, you'd have to go through and say, like, you'd want to think of all your perfect squares: 1, 4, 9, 16, 25, 36, 49, so on and so forth. And you'd basically have to try to divide this by each of these numbers. Okay, and if it came out to be a whole number, then you'd be in a good shape. Now, the number that they're saying that it divides by evenly is 25 squared, which is 625. Now, I cannot in any way look at this thing and just say, okay, that is 625 times, what number did they get? 1285? Okay, I'm not going to be able to look at this number and just pull this out of nowhere. Nor do I even know off the top of my head that this is a perfect square number. You know, I run out of my perfect squares at about 13, I think, right? 1, 4, 9, 16, 25, 36, 49. That's 7, so 64, 81, 100, 121, 144, 169. I think 13 squared is the highest one that I have memorized. So after a while, it's going to be pretty hard to do these simplifications. However, they want an approximation as a decimal anyways, so we wouldn't really need to do this simplifying step. We would just go and say square root of 803, 125. Okay, on Google, I always just do it this way. I type in SQRT, which stands for square root, and then type in the number you have, 803, 125. And they'll tell you what the square root of that number is, and they'll cut it off at some point. So this decimal may actually continue for a while, but we can just kind of approximate and say 869.17, which is the answer that they were looking for. Cool. So that's the process. It's all the same. We're just dealing with larger numbers this time around.